Okay, live start చేశాను.
Okay, Bhaiya.
Good evening, students. Today's resource person is a well-known person, Dr. Vasam Sreenivas sir. మనకి ఇక్కడ ఫ్రీ కోచింగ్ స్టార్ట్ చేసిన వాళ్ళు సార్ ఈజ్ వన్ ఆఫ్ ది ఇనిషియేటర్స్ అనమాట. ఇక్కడ మొత్తం కేడీసీలోనే వర్క్ చేసినప్పుడు సార్ యూస్ టు కోఆర్డినేట్ ది ఇంటైర్ ఫ్రీ కోచింగ్. ఇనార్గానిక్ అంటే ఫస్ట్ గుర్తొచ్చే పేర్లలో సార్ హ్యాస్ మోర్ దెన్ 30 years of experience at various levels, పీజీ కోచింగ్, తర్వాత MSET, IIT, JEE, NEET and other things. So, Bhaiya, thank you very much for accepting our invitation and taking this.
Thank you, Bhaiya. Thank you so much. Thank you, Bhaiya. Okay, నేను 7:30 ఓకేనా? 7.
తర్వాత మీరే ఇంకా క్లోజ్ చేసేసేయండి.
7 o'clock క్లోజ్ చేయనా?
రైట్. మిమ్మల్ని హోస్ట్ చేయాలి, మరి హోస్ట్ చేసి లీవ్ అవుతాను.
ఓకే.
తర్వాత మీరు ఎండ్ చేస్తే డైరెక్ట్ ఎండ్ చేసేయచ్చు.
ఎండ్ చేస్తాను. ఓకే.
రైట్.
థ్యాంక్ యూ. రైట్.
Now you are the host.
Okay.
Right, Bhaiya. Thank you very much.
Right, Bhaiya. Right. So, good evening, dear students. So, sir.
Good evening, sir.
Good evening, all of you. Now, today, we are discussing about PBlock elements. It's a part of inorganic chemistry. And you know the inorganic chemistry syllabus, just you see the important areas. For example, you come to the preparation for inorganic chemistry. The first lesson is
coordination compounds.
No. The sequence important here. The sequence is periodic table. It is not mentioned in our syllabus, but the periodic table is also the fundamental lesson for the remaining inorganic chapters. So in periodic table, you have to concentrate. First of all, the periodic properties are very important in periodic table. The second lesson is the most important for entrance point of view, chemical bonding. So the chemical bonding, including molecular orbital theory. So from this lesson, we are expecting 2 to 3 questions every year. Any examination, either CU, CPU, Central University or state universities. So one question we are expected from lone pairs on central atom, you remember. And second question we are expecting from number of sigma bonds and number of pi bonds around the central atom or around whole molecule. This type of question also we are expecting. And third question we are expecting from hybridization and geometries. And fourth one, bond calculation of bond order. Okay, na? Bond order including bond length, bond energy, and bond order. So BO, calculation of BO. So NB minus NA by 2, the formula. So these type of 4 questions we are expecting from chemical bonding, including molecular orbital theory. And after these 2 lessons, the continuation connecting link with the S-block elements. So syllabus lo manaki ichina mention chesina cheyakunna we are expecting one question from S-block elements. So and S-block lo for containing first year and second year group elements. Here some properties, some hydrolysis reaction, heat of hydrations, and some physical properties, some chemical properties important from S-block elements. And after S-block elements, the next lesson is PBlock elements. You know the PBlock elements containing total 6 groups, including noble gases. So noble gases, along with the noble gas, the remaining from 3rd A to 7th A. So the 6 groups belongs to PBlock elements. I think we are expecting from the PBlock elements around 3 to 4 questions. So నేను ఏం చెప్తున్నాను ఇందాకంటే periodic table and chemical bonding. Okay, so the 2 lessons indirectly supporting to the PBlock elements preparation. మీకు PBlock elements preparation thorough కావాలి అంటే మీకు ఏముండాలంటే periodic properties ఐడియా ఉండాలి and chemical bonding ఐడియా ఉండాలి. Why? Because you come to periodic PBlock elements. For example, 3rd A group, 4th A, 5th A, 6th A, 7th A, 8th A, the group compounds, chemical compound, for example, chlorine compounds and phosphorus compounds, nitrogen compounds and phosphorus compounds are different compounds. Every compound you have to study the structural information and the number of sigma, number of lone pairs, hybridization, geometry, and number of the central atom oxidation state. So these are all the characters you have to explain about the compounds, particular compounds. You ravali ante you thoroughly you prepare the the periodic properties and chemical bonding lesson. Okay. After the P-block elements, you go to the next lesson, inorganic area, D-block elements, and the next one, A-block elements. So SPDF in periodic table finish, and you go to coordination chemistry. This is the most important lesson for competitive examination point of view. You're expecting around 10 questions, 10 to 12 questions from this lesson. So the coordination chemistry, part 1, part 2 in degree level you are studied. So Werner's theory, valence bond theory, Sidgwick theory, and crystal.
Yes.
So they are all the most important lesson from inorganic chemistry, that is, and UPS nomenclature and isomerism, ligand data. So calculation of CFSE, crystal field stabilization calculations, and these are all the label compounds, inert complex. So the most important, this one. After coordination chemistry and its applications, you go to the next lesson is metal carbonyls and metal nitrosyls. So metal carbonyls also part of coordination compounds, nickel tetracarbonyl and iron pentacarbonyl, like this. So this lesson also one of the topic in inorganic chemistry. And the next one, the theories of bonding in metals. So it is also one of the, just like metallurgy, the metals theory, bonding theories in metals. That is also one of the inorganic chemistry topic. And the next one is HSAB theory, Pearson theory, as odd acid and odd base and soft acids of HSAB principle or Pearson theory. So we are expecting for 1 question or 2 questions from HSAB principle, this one also. And the next one, bioinorganic chemistry, especially bioinorganic means and hemoglobin and chlorophyll and structures and central atom oxidation states and cytochrome, for example, the oxidation, for example, the oxygen carrying hemoglobin functioning. These are all the comes under inorganic chemistry. Some vitamin B6 and B12 also there. They are all the inorganic, bioinorganic chemistry or bioinorganic coordination chemistry. That's one of the lesson. And the next one, OMC, organometallic compound. It is also treated just like in organic chemistry, organometallic compounds classification and OMC and preparations and structures. The RMGX, the Grignard reagent, is the best example for OMC. And alkyl lithium also there, RLI and RMGX. These 2 compounds are we are discussing thoroughly from the OMC. And the last one, theories of qualitative analysis, like salt analysis methods. So this is also one of the lesson is there. So this is the brief areas, the syllabus of PG entrance examination from inorganic area. So from inorganic chemistry, we are expecting from around out of 100 questions, 30 to 35 questions. So 30 to 35 questions from inorganic area. Out of the whole inorganic area, the first lesson is chemistry. Yes? What? Not clear.
Central University, sir.
Yeah, same syllabus. Already I seen the syllabus. So these syllabus almost all covered in Central University examination also. Same.
Sir?
Most. You remember the majority of the lessons are same. So 1 or 2 lessons are variation, but the remaining, the all now in Japan, chemical bonding, periodic table, coordination chemistry, and everything, SPDF block, all are comes under any examination point of view, not only central, not only state university, CP gate. Any examination, the main inorganic area, this is the inorganic area. So now come to our topic. Today I'm discussing about the P-block elements. So
Sir, P-block like in 11 marks and mention sir, PGC syllabus la.
Yes, depends upon question paper setting. The whole molecule around 30 to 35. Okay, na 30 to 35 మాత్రమే మన కెమిస్ట్రీ ఇనార్గానిక్ లో వస్తాయి. So, for example, sometime depends upon paper setter, we are expecting more questions. Maximum, minimum 5, maximum 7, 8, maximum 10, అంతకంటే రావడానికి లేదు. So, for example, S block లో 2 questions, P block లో 6 questions, and hybridation, ఇవన్నీ కలిపి more than 10 అవుతాయి కదా అట్లా. కాబట్టి you remember each lesson. For example, now you see this is P-block elements. So each group we are expecting 1 question. For example, boron family, here carbon family, nitrogen family, oxygen family, and halogens and noble gases. Sometimes we are expecting 2 questions from noble gases. one question from third group. Overall, the 6 groups into each question, each group one question eskunna, you are getting 6 questions. And S block lo 2 questions, 6 plus 2, 8. Okay, na? And hybridization related questions, chemical bond related, also part of PBlock elements, avaku 2 questions. The indirect మీకు ఏమవుతుంది more than 10 అవుతున్నాయి. So that's why you remember it is a part of big lesson, and along with the coordination chemistry, ఈ రెండు కనుక ప్రిపేర్ అవుతే maximum మనకి ఇనార్గానిక్ ఏరియాలో స్కోరింగ్. You remember in chemistry entrance examination, the scoring subject is inorganic chemistry. So exactly మీకు స్కోర్ అవుతాయి ఈ టాపిక్ అన్ని కూడా. You can prepare thoroughly, proper గా ప్రిపేర్ అవుతే ఇందులో maximum స్కోర్ చేస్తారు. It is a scoring area. Inorganic chemistry is scoring subject. So మీకు ఆన్సర్ వస్తేనే సడన్ ఆన్సర్ పెడతారు, అదర్వైజ్ లీవ్ ఇట్. కంపల్సరీ only inorganic chemistry. So now this is the brief information and discussed about the chapters, subtopics in inorganic chemistry. So now come to our main topic. Is today we are discussing about PBlock elements. You know the PBlock elements, what is PBlock elements and how the classified as P, D, F, you know everything, the fundamentals. And these are the PBlock elements. The PBlock elements containing 6 groups and third A2, and this is 8th A, 6th A. So these are the elements, and you see, remember, so these are all the color, different colors are shown here. For example, the pink colors, they are all some area, and helium, and these are the metals, and this area, boron, silicon, germanium, arsenic, antimony, and tellurium, they are all the semi-metals or metalloids, and remaining pink color shown, these elements are belongs to non-metals. And helium is a non-metal, but it is treated as a gas. These are all the gaseous elements, and these are all the group elements. And now the next one, the group-wise studies. This is the most important. Suppose you take any group from 3rd A to 8th A. So these are the important points we are discussing in each group. One is, first point is group-wise studies. Number 1 point, group elements. And second one is electronic configuration. And third one, oxidation state. And fourth one, inert effect. Okay, inert effect. And these are the elements. And now the properties are 2 properties. One is physical property and second one chemical property. Sometime we are expecting 1 or 2 questions from physical. And second one, the most important area is chemical properties. Any group you go to, after some property, group elements, electronic configuration, oxidation state, and inert effect, you go through next properties, physical and chemical. And now the physical properties. The most important physical properties in each group. One is physical state, whether it is a solid or liquid or gas. For example, you take noble gases, all are gases. For example, you take halogens. These are the halogens. You see, these are the halogens. The fluorine, chlorine are gases, and bromine is a liquid. The iodine is a solid. The physical state from top to bottom change. Liquid gases to liquid, liquid to solid. You come to noble gases, all are belongs to gases, right? So these are the physical state. And the next one, melting point, boiling point. Okay, so for example, you take a 4th A group, the allotropes of carbon, the diamond exhibiting highest melting point, around 4,200 degrees centigrade, the melting point value. Okay, so if you take helium, the minus 2.2 kelvins. So these are the depends upon the bonding nature in the metal element. The melting point, boiling point also difference here. That is the melting point, BPT, MPT. You come to the metallic nature, whether it is some, now just now I told you. So these are the metals, semi-metals, and non-metals. So in the entire periodic table, the periodic table containing now 118 elements, out of 118 elements, 11 elements are gases, and 17 to 18 elements are non-metals, but the remaining majority of the elements are belongs to metals. So that is the classification of elements in the periodic table. And the next one, atomicity. That is the most important. You know the atomicity. Atomicity means the stable form of molecule. For example, you take atomicity of nitrogen 2. 2 nitrogens combine together to form N2 molecule. The atomicity of oxygen 2. Always the stable form of oxygen is O2. The fluorine F2, Cl2, Br2, I2. So these elements, the atomicity always 2. You come to phosphorus. The stable form of phosphorus always the state
P4.
in P4 state. So 4 phosphorus atoms are combined to form a P4 molecule. So the atomicity is 4. You come to sulfur, the atomicity 8. 8 sulfurs are associated to form a stable sulfur molecule. So 8 sulfurs are associated here. That's why the sulfur atomicity 8, the phosphorus atomicity 4, and the nitrogen, oxygen, and all halogens are 2. You come to noble gases, even the single atom, they are stable. That's why the atomicity of noble gases is 1. That's why they are called monoatomic gases. These are all monoatomic gases, right? So this is the one property. And the next one, allotropy. It is also most important physical property. You know, the allotrophy means the element, the same element can exhibit different form. For example, you come to 4th year group elements carbon. The carbon exhibit a different form of allotropes, crystal allotropes and amorphous allotropes. Crystalline, for example, diamond, graphite, and Buckminster, fullerene, all are comes under carbon allotropes. And sulfur also exhibiting allotrope forms. And phosphorus exhibiting red phosphorus, black phosphorus, white phosphorus. And in nitrogen also, they are alpha nitrogen, beta nitrogen. They are all the allotrope. Allotrope means the element can exhibit different forms. The chemical property is the same, but the physical property is different. That nature is called, that phenomenon is called allotropism or allotropy. So the maximum majority of the elements are exhibiting different allotropic forms. So that is the allotropy. So these are the physical property, physical state and melting point, boiling point, and metallic nature, and atomicity, and allotropes. And you come to the next colors. Some elements, for example, noble gas, for example, halogens are exhibiting different colors: yellow, yellow-green, reddish, brown. For example, fluorine, chlorine, bromine. Why? Because the elements are having odd electrons. So even electrons, they are not exhibiting colors. If the element having any odd electron is there, that elements are exhibiting colors. So no halogens are exhibiting colors. And some elements, for example, magnesium and calcium, on burning, they are exhibiting different flame colors. So that is also reason is there. I will discuss later. And color property. And these are the period. Just now I told you the periodic properties. These are the important periodic properties. One is the ionization potential and electronegativity and electron affinity and electropositivity. And these are all the important periodic properties. How for change from top to bottom ionization potential value. The electronegativity value, how change from in a group and in a period. And electron affinity values, how the changes from top to bottom. Electropositivity changes. So the 4 periodic properties are most important for examination point of view. For example, you see electron affinity, electronegativity. In entire periodic table, which element having highest electronegativity value according to Pauling scale? In entire periodic table, 118 element, only one element, that is called fluorine, exhibit highest electronegativity value in entire periodic table. And electron affinity, and which of the following elements exhibit highest electron affinity value, and which of the following element exhibit highest electropositivity, and which of the following element exhibit highest ionization potential value or lowest ionization potential value. So these are the different type of this type of questions they're expecting from examination point of view. That's why every student, you must read the periodic properties. So what is IP definition and then applications? Electronegativity definitions, its applications in a group and a period. Electron affinity, electropositivity. After that, the next important area, diagonal relationship. It is also very important property. Only the first, second row and third row group elements. So that elements can exhibit this type of property, diagonal relationship. So this is next later we will discuss about what is a diagonal relationship and examples will be shown. The next one, after that, you go to after physical property, the important one is chemical properties. So the first 4 properties are most important we are expecting from examination point of view. So the first property is hydrates, and second one halides, and third property is oxides, and fourth property oxy acids. and other properties. Leave it about the fifth one, but you focus on the 1, 2, 3, 4. So every group elements, they can form hydrates, they are forming halides, oxides, oxyacids. As a student, first you learn what is hydrates. First you read about what is halides definitions and what is oxides and what is oxyacids. So hydrate means what? You see any group element, either S block or P block or D block or F block, any element in the periodic table, when react with the hydrogen, gives certain compounds. The compounds are called hydrates. For example, you take sodium. The sodium react with hydrogen, gives sodium hydride, NaH. You take calcium, react with hydrogen, gives CaH2, calcium hydride. Right. So the hydrides means when react with hydrogen. So that is one property. We will discuss later one by one. And second one, halides. Halides means halogens. Any element when react with halogens, you know the halogens are 4, denoted by capital X. For example, they are fluorine, chlorine, bromine, and iodine. So the 4 elements react with any element in the periodic table gives certain compounds. The compounds are called halides. The simple statement, react with the halogen gives halides. And the third one is oxides. Very simple. Any element in the periodic table, when react with the oxygen, gives oxides. For example, you take sulfur. The sulfur react with oxygen, gives SO2. You take carbon with oxygen, gives carbon dioxide, CO2. Right. You take xenon, react with oxygen, gives xenon, O3 and O4, like this. So any element when react with oxygen gives oxides. So you remember each group elements can form hydrates, halides, oxides. And the next one, oxyacids. Oxyacids means any oxide when dissolved in water, any oxide of a different group like 30A, 40A, 50A, 60A or 70A. Any group element oxides when react with water or when dissolved in water, they produce acids. That acids are called oxyacid. For example, the best example you take boron, right? The boron react with oxygen gives B2O3. Boron trioxide is an oxide of boron. The boron oxide when dissolved in water gives boric acid, is a oxyacids. So oxides dissolve in water, they produce oxyacids. So that's why in each group, for example, 3rd A, 4th A, 5th A, 6th A, 7th A, each group first each you can study systematically. So it was step by step. First hydrates, halides, oxides, oxyacids. So man em cheyali ikkada structural information important here. Hydrate structures, hydrates hybridization, and lone pairs and bond pairs, oxidation state. You come to halides structural information, oxides structural information, and oxyacids structural information. Very, very most important for examination point of view. నేను అందుకని మీకు ముందే చెప్పాను, కెమికల్ బాండింగ్ అనే లెసన్ కనుక క్లారిటీ మీకు వచ్చేస్తే యూ కెన్ రీడ్ థరోలీ హైడ్రేట్స్, ఆలైడ్స్, ఆక్సైడ్స్, ఆక్సైడ్ స్ట్రక్చర్స్ అన్ని వచ్చేస్తాయి. సో వీటికి బేస్ ఏంది అంటే ద ఫస్ట్ లెసన్ ఈజ్ పీరియాడిక్ టేబుల్ అండ్ సెకండ్ బేస్ లెసన్ ఈజ్ కెమికల్ బాండింగ్. ఓకే, ఈ రెండు కనుక క్లారిటీ ఉంటే యూ కెన్ థరోలీ కెన్ రీడ్ all chemical properties of individual groups in PBlock elements. Okay, so this is the outlines, the general information about introduction of PBlock elements. ఇన్ని రకాల ఇంట్రొడక్షన్ మీకు ఇచ్చాను, సో మీకు ఐడియా ఉంది. సో ఇవన్నీ మనం కవర్ చేయాలి. సో ద ప్రాపర్టీస్ ఆర్ 2 ప్రాపర్టీస్ ఇంపార్టెంట్, ఫిజికల్ అండ్ కెమికల్ ప్రాపర్టీస్. సో వన్ ఓకేనా? నౌ కమ్ టు these are the previous questions for entrance examination questions, model questions. Before we are entering into our lesson, just the outlines, there are some questions. You see 1 or 2 questions, idea purpose. Al4C3, this is called aluminum carbide, is an ionic carbide, name as. Okay, the Al43 is an ionic carbide named as, but common name in D. It names each other. Answer is so AlCl3 on hydrolysis gives ABCD mentioned here. Okay, And which of the following is an electron deficiency molecule? Options are lithium hydrate, diborin, lithium borohydrate, and borozole. So 4 options mentioned here. The question is, which of the following is an electron deficient molecule? So the answer is, you know already, that is the one, the famous, that is called diborin. Diborin is the electron deficient molecule. Okay, so these are the few questions from third year group element. And some another questions also there. The possible oxidation state of thallium. So ఇది చాలాసార్లు అడిగాడు క్వశ్చన్. ఇందాక నేను చెప్పాను ఇనర్ట్ ఫేర్ ఎఫెక్ట్ అన్నాను. సో దాని రిలేటెడ్ క్వశ్చన్. The possible OS of thallium. Thallium belongs to boron family. Okay. The boron family common oxidation state +3. 3 ఉండాలి. But due to inert pair effects, the thallium exhibiting only +1, not +3. Therefore, the thallium OS +1. And but the group common is 3. Thallium individually shows +1. And which of the following sublime on ET? So these are the some questions we are expecting third year group element. You come to fourth year carbon family, some questions. The lead tetraiodide does not exist because silicate having one monovalent corner oxygen atom in each tetrahedron unit is. Very important questions. The gaseous product of reaction between tin and concentration H2SO4 is. And the dehydration of melanoic acid with phosphorus pentoxide gives. Very, very important question from competitive exam. Which of the following is springly soluble in cold water and fairly soluble? So this is also one question we are expecting from. These are the model questions from fourth year group elements. And the silicon dissolve in excess of HF due to formation of. And which of the following halides does not hydrolysis at room temperature? And silicon tetrachloride on hydrolysis gives. And which substances is having molecular solid? Okay, so these are the model questions from fourth year group elements. And you see, you observe the nitrogen family at 15th year group. The mixed anhydrous of nitrogen is. Excellent question. And among ammonia, phosphine, arsine, stibine, which one is a stronger reducing agent? చాలాసార్లు ఈ క్వశ్చన్ ఎక్స్పెక్ట్ చేయొచ్చు అని అడుగుతున్నాడు దీని కాంపిటేటివ్ లో. స్ట్రాంగర్ రెడ్యూసింగ్ ఏజెంట్. With answers, ఇక్కడ ఆన్సర్ D is right answer. But why the D is right answer, I will explain in the 5th year group elements. And just you observe the questions and you see the model questions. And now come to 38th question here. The products formed by the complete hydrolysis of PCl3. So when PCl3 dissolve in water, they produce phosphorus acid plus HCl. Right. The which of the following order regarding thermal stability of hydrolysis? MHE3. MHE3 means the 5th group hydrate general formula is MHE3. M is 5th group element. This is hydrogen. The 5th group element when react with hydrogen gives MHE3 formula of hydrates. So the MHE3 of 5th group is correct. This is the order. Okay. So these are all the 5th group questions. And now come to 6th group elements, model questions. The SO bond length is maximum. SO bond length. And in case of hydrate of oxygen family, which of the following physical property change on moving down the group? Okay, the hydrolysis of 1 mole of peroxide disulfuric acid produced. Very, very important question, hydrolysis. You remember indaka meeku cheppanu nenu. So మీరు చూడండి మోడల్ క్వశ్చన్ చూస్తున్నారు. Every time in a from 3rd year to 8th year, the hydrolysis reactions are most important here. And hydrates when dissolved in water, what is the product is formed? Halides when dissolved in water, what type of compounds are produced? So any compound when dissolved in water, ఏం ఫామ్ అవుతుందంటే all hydrolysis reactions are most important in PBlock elements. And in trimer form of sulfur trioxide, each sulfur atom is bonded with. This is also one important question in 6th year group elements. And you come to 7th year. In which case the order of acidic strength is not correct. ఇక్కడ ఇచ్చాడు డిఫరెంట్ ఆలైడ్స్ ఇచ్చాడు, హైడ్రేట్ ఇచ్చాడు, ఫ్లోరిన్ ఆక్సైడ్స్ ఇస్ మెన్షన్ హియర్ అండ్ డిఫరెంట్ HF, H2O, NH3. So they are asking not match correct answer, strength, acidic strength paranga not correct matching అని అడిగాడు. And the next 55 questions, the concentrated nitric acid react with iodine to give thermally the most stable compound is, and the interhalogen which does not exist is. So మరి అందరు interhalogens మనం డిస్కస్ చేద్దాం in 7th year group, but one of the interhalogen does not exist అంట. So what is that? You see IF5, ClF3 and BrCl, ICl4. So ICl4 does not exist here because of AX type, AX3, AX5, AX7. So 4 types of interhalogens are formed, but AX4 అనేది ఉండదు ఇక్కడ. So therefore the D is wrong option. And which of the following disproportionate in water? Disproportionate means the halogen when react to water, the remaining మిగతా ఎలిమెంట్స్ కంటే డిఫరెంట్ గా ప్రొడక్ట్స్ ఫార్మ్ చేస్తే దట్ ఇస్ కాల్డ్ డిస్ప్రపోర్షనేట్. అది ఏ ఎలిమెంట్ అనేది అడుగుతున్నాడు ఇక్కడ. ఆల్ ఆర్ సేమ్, ఎనీవన్ డిఫరెంట్ అంటాడు. సో ద ఫ్లోరిన్ ఈస్ డిఫరెంట్ కాంపౌండ్స్ ఆర్ ప్రొడ్యూస్డ్ బికాస్ ద ఫ్లోరిన్ ఈజ్ ఏ హైలీ electronegative element comparatively other halogens. That's why the fluorine generally we called super halogen antaru. So due to the over at a highly electronegativity, the fluorine can form different compounds when dissolved in water. So we will discuss about the halogen properties. And the last PBlock element is noble gases. You see the one question, the compound cannot formed by xenon is. Same question. The noble gases can be separated by, and which of the following xenon has the same number of lone pairs in I3 minus? ఇక్కడ చెప్పాను చూడండి, లోన్ పేర్స్. ఈ క్వశ్చన్ ఇందాక మీకు చెప్పాను, ఎక్కడ వస్తుంది లోన్ పేర్స్, బాండ్ పేర్స్ ఇన్ కెమికల్ బాండింగ్. సో కెమికల్ బాండింగ్ థరో ఉన్నట్లయితే ఈ లెసన్ ఇండైరెక్ట్ గా ప్రిపరేషన్ ఫినిష్ అవుతుంది. సో లోన్ పేర్స్ కానీ, బాండ్ పేర్, నెంబర్ ఆఫ్ సిగ్మా, నెంబర్ ఆఫ్ 5 bonds అండ్ హైబ్రిడైజేషన్, జామెట్రీ అండ్ ఆక్సిడేషన్ స్టేట్. సో ఈ ప్రాపర్టీస్ అన్ని ముందు థరో అయితే you can easily understand about the PBlock elements from 3rd year to 8th year. And now, so this is the basic information and along with the model questions completed. Now come to our real topic is 3rd year group element. It is the first PBlock element in the periodic table. So 3rd year group elements. So you know the 3rd year group elements, all of you, the boron, aluminum, gallium, indium, thallium. Right, the symbols are there here. You see the electron configuration also there. So here, these are the boron family and 5 elements are there. Now the elements boron, aluminum, gallium, electronic configuration NS2, NP1, NS2, NP1. So this is the electronic configuration. But you see the common oxidation states. This is a +3. 3 electrons are excess for going to octet configuration. 3 electrons are excess in each element. So that's why all 3rd year group elements are exhibiting +3 oxidation state. But one special case here, in case of thallium, thallium is a big size, but what happened due to inert pair effect? Inert pair effect means the NS2 electron does not involve in the chemical bonding. So the electrons participate kavu due to lanthanide contraction. So only the 1 electron of a P involved in the chemical bonding. That's why the thallium exhibiting +1 oxidation state only, not +3. Okay, remaining elements all are shows +3, but in case of thallium shows only 1, that is called +1 oxidation state. So the reason is inert pair effect. So inert pair effect goes due to lanthanide contraction. So you remember in the group only the thallium shows different oxidation state, that is called inert pair effect. And now come to the melting and physical properties, melting and boiling point value. You see remember the boron melting point 2000 above and 3600 above. Aluminum, right? Okay, indium. And you see the differences between melting and boiling point. The difference value, indium is shows. The gallium 30 and 2403. The difference is more in case of gallium, right? This is most out of the 5 elements, the gallium is most important because the difference, you remember the difference, this difference is more difference, maximum difference between melting and boiling point value. So gallium. So you see that is called the liquid range. That generally we call the differences between MPT and BPT is called liquid range. The gallium is used in the preparation of a special type of thermometers due to high liquid range. You remember the most important point. So the gallium is always available in the Ga2, gallium 2. Okay, it is a liquid element. So due to the different liquid range, the gallium you have to using in the preparation of special type of thermometers. So gallium molecular state is Ga2, gallium 2. Okay, and the next one, and IP value, and the common oxygen state place 3, but thallium is a place 1 due to inert variable, you know already. Now you come to properties, chemical. So the physical property only, inert pair effect and liquid range, 2 points are important in physical property. You come to chemical property from third year. So these are the chemical properties of third year. Hydrates are there, oxides are, hydroxides, halides, and oxyacids. Okay. Now come to hydrates. Just now I told you the hydrate means the group element where react with hydrogen gives hydrates. You know that is the definition already. Now the hydrates are, for example, the first element here, boron. The boron react with hydrogen gives boranes. You remember the boron hydrate is called boron. So boron react with hydrogen gives boron. The borans are 2 types here. One is nidoboron and second one archinoboron. Chala salu adigaru competitive lo. What is the chemical formula of nidoboron? And which of the following is the right formula for archinoboron? So the nidoboron, archinoboron, both are combined to form, they belongs to boranes of boron. So the boron hydrates are called boranes. Boranes are 2 types, nido and archino. Nido general formula BnHn plus 4 and archino formula BnHn plus 6. Right? So these are the examples, nidoboron, archinoboron, BnHn plus. The best example is a diboron. Our diboron belongs to nidoboron. And tetraboron and pentaboron 9, hexaboron 10, 9, 10, 12 are belongs to number of hydrogens here. And here archinoboron's formula. But out of the borans, in our syllabus, we have discussed about diboron and other borans structures, also important. Now, first you come to diboron. Chala sarla, competitive law, we are expecting one question from diboron. So already studied in intermediate level and degree level also. But the diboron, especially structure of diboron is most important here. You see the first diboron preparation method and physical property, chemical property, and structural information. And the first you come to structure. You know already the structural information. You remember the B2H6, the molecular formula similar to ethane, C2H6 laga untundi. B2H6 and C2H6 both are same molecular formula. But C2H6 containing 14 valence electrons. Why? Because each carbon 4 electrons valence electrons, C2 2 into 4 8, and 6 each hydrogen 1 electron, 6 into 1 6 plus 8 to 14 valence electrons are present in ethane molecule C2H6. Whereas you come to B2H6, the boron valence electrons, each boron containing 3 plus 3 6, and each hydrogen 1, 6 hydrogen 6 into 1 6, therefore 6 plus 6 is 12, right? So the diboron containing 12 valence electrons and ethane containing 14 valence electrons. But ethane is a stable molecule, but diboron is a unstable electron deficiency. How much deficiency here? 2 electrons are deficiency. So 2 electrons are deficiency. So that's why the diboron is a electron deficient molecule. Whereas in C2H6 is a electron saturated, electron sufficient molecule. So this deficiency in control cheyadam koraku diboron can form the new bonds, that is called overlapping bond, that is called banana bonds. These are the new bonds are formed between 2 borons, BHB, BHB, right? These bridge bonds. So these bridge bonds though are 2 electron deficiency overcome out. You remember that point, very, very important here. So our 2 electron deficiency control chesukodaniki, overcome chesukodaniki, the 2 borons can form a bridge bond, that is called BHB. BHB2 bridge bonds. The bridge bond generally we call banana bond or a tau bond or 3-centered 2-electron bond under. So in BHB centers are 3, but the sharing of electrons are only 2. That's why that is called 3-centered 2-electron bond. Okay, right. These are the another names of BHB bond names. Right. So this is the structure of diborane. The BH, the terminal, these are the terminal bonds 4, and these two are a bridge bond. The terminal bond BH bond length 1.1 angstrom units. The bridge bond BH bond length 1.33. Right. This is the bond length between BH and BH. And two bridge bonds. The boron hybridization, sp3 hybridization, because 4 indirectly 4 bonds are present around the boron. And this is the structure, BHB structure. This is the most important. So the terminal bonds are BH, 4 terminal bonds, 4 hydrogens are T hydrogens, terminal, and 2 hydrogens are B hydrogens. B means bridge hydrogens. The total hydrogens are 6, and bridge bonds are 2 bridge bonds, BHB. And this bridge bond, another name is tau bond or banana bond. And this BH is called 2-centered 2-electron bond. And this bond is called 3-centered 2-electron bond. This is electron sufficient bond. And this is electron deficiency bond. So this is the information about diborane. And next one important one, for examination point of view, for entrance point of view, this reaction, very, very important. When, what is that? The diborane react with ammonia. So these 3 reactions, you remember, we are expecting one question from entrance point. Any examination point of view, we are expecting from question from reaction with ammonia. You see the left side, all are diboranes. Diborane, diborane, diborane. All diboranes are reactive with ammonia, but the conditions are different. In the step 1, first reaction, you have to take an excess of ammonia. Okay, the diborane react with 2 moles of ammonia, and you see low temperature, you are getting diammonium of diborane. It is a coordinated covalent bond. Okay, this is Lewis acid, and this is Lewis acid, this is Lewis base. Lewis acid and Lewis base gives this is day 2 bond. Day 2 bond presented diammonium of ammonia, diammonium of diborane. And you come to the second one. Diborane react with excess at hot condition, HT, high temperature, low temperature, high temperature. You are getting a polymer compound, BNX. It's a polymer compound. The name is boron nitride. Right? The same way, same diborane and react with ammonia, the ratio 1:2 ratio at a high temperature. Here excess of ammonia, but here mentioned 1:2 ratio. You are getting the compound B3N3H6. This compound name is called borozole or borozine or inorganic bench. 3 names. So 3, one is diammonium of diborane, boron nitride, and borozole, or generally we call inorganic benzene. Okay, man, chuddam malli structure 1 by 1. These 3 reactions are very, very important. All are react with ammonia. And the next one. And this is the structure of boron nitride, similar with graphite. Graphite is a layered structure. Hexagonal rings are there. Same boron nitride also layered structure. Hexagonal rings are there. Yes, this is the BN, BN, BN. So alternative atoms are there. And this is layer 1, layer 2, layer 3. And each layer, in between layer, van der Waals attraction forces are there. But overall, you see the layered structure. Indirectly, hexagonal rings are present here like this. Here the graphite structure also same. So double bond, and all are 6 carbons here, but here alternative boron nitrogen bonds are there. This is called boron nitride structure, and this is graphite structure. So the boron nitride structure similar to graphite. And the next one, this is borozine and borozole structure. Borozine, right? This is B3N3 structure. This is similar to benzene structure. Same benzene ela undo alanam. Okay, so that's why it is a generally we call this is organic benzene and this is called inorganic benzene. The common name is inorganic benzene, borozole or borozine or inorganic benzene, and this is borozole structure. And but here you remember this is purely covalent bond present here. covalent bond in between CC and CH, all are sigma bond, pi bonds are present here. But you come to here, you see the nitrogen having lone pair electron, donating boron side. That's why this is donor and this is acceptor. Okay. And the nitrogen is a donor Lewis base and the boron is a Lewis acid. Between nitro boron, coordinate covalent bond formed here. One is a sigma and remaining is the day2 bond. Sigma and day2 bond. Sigma, day2 bond. Day2 means the nitrogen is a donor and boron acting as an electron acceptor. So that's why this is also the structure of borosol. Generally we call borosine. And now the important is differences between borosol and benzene. Right? And now you see the important between the differences between borosol and benzene. So the most important for examination point of view, you see the borosols already seen the borosol structure and benzene structure, but BN bond is a polar. Why? Because N is a donor and boron is a accept plus minus. But here, whereas in CC bonds are non-polar. Here the pi bond is a day2 pi bond. Already I told you one sigma, one day2. But here the pi bond is a covalent bond. Easily undergo addition reaction, but the CC bond are non-polar, so it is undergo electrophilic reactions, substitution reactions. And borosol is a less stable and benzene is stable, and it undergoes hydrolysis but does not undergo hydrolysis. So these the differences are most important for entrance point of view in between the borosol and benzene. And you see the addition reactions of borosol, the B3N3S6, addition with the HCl gives the compound like this. You see the HCl H plus and Cl minus, addition with the boron nitrogen are getting is a compound. And second one is hydrolysis reaction. The borosol when dissolved in water, they produce one is ammonia, and the second most important compound is boric acid, and third one is hydrogen gas is liberated. So boric acid is formed. So these are the addition reactions and hydrolysis reactions of borosol. And now the diboron properties. Diboron react with water. Borosol. This is BOH taken thrice. You can write reverse H3BO3 boric acid, and addition reaction methyl hydroxide methanol and ether, thioether and lithium hydrate and HCl and Cl2, the common properties. And you see, you come to higher borins, just like now I told you the different borins, the nidoborins and oxynoborins there. You go any higher borin, these are the possible bonds. We have to, there one is terminal BH bond and BB bond and BHB bond and BBB bond. And so these are the four bonds we have observed in higher borins. Just now I told you in diborin, we have observed only two types of bond. One is BH bond and second one BHB bond. Right. This is a three-centered bridge bond, including BHB in diborin, three-centered two electron bond. And terminal bond also there, the non-terminal covalent bond and two-centered two electron bond. Along with the two, the remaining two bonds also we observed in higher borins, that is called BB bond and BBB, like this, BBB. So three-centered two electron, two-centered two electron bond. The four bonds are possible and observed in higher borins, like this. You see, these are the higher borins, diborin, tetraborin, pentaborin, and like this. And the structural information of diborin, and like this. These are all the higher boron structures. And now come to, this is aluminum hydrate or boron hydrates, BH3. Now you come to aluminum react with hydrogen are called, the boron hydrates are called borins, but aluminum hydrates are called alane. The general formula AlH3 taken thrice. It is a polymeric state like this, aluminum. Each aluminum containing 6 bonds, octahedral geometry. It is carrying 3-centered bond. And each aluminum atom is occupied by 6 hydrogen atoms in octahedral geometry. So this is the most important. Each aluminum containing 6 bonds, so like octahedral geometry. So this is the bridge bond also present here, ALH also there. And this is GaH3, the gallium hydrate is called galane, and indium InH3 is called indane polymeric solid, and TiH3 is called extremely unstable. So the gallium H3 is called volatile oil. Why? Because the gallium is a liquid state available. That's why the gallium is available unstable volatile oil. Okay, this is the most important. So you remember the names, very important. Boron hydrate is called borin, and aluminum hydrate is called alane, and gallium hydrate are called galene. So galene, so is the volatile oil. And these are the reaction with the borons, not important here. And the reaction with the other metals, leave it. Now come to boron oxides. So the boron react with hydrogen, borins completed. The next property oxides, the boron oxides and borax and aluminum oxide. And you see the boron oxide B2O3. How can you prepare? First, you take orthoboric acid. And you remember this reaction is most important, available in material also. And there you see the B2O3. You remember all of you. Generally we called boron trioxide. Generally, the another name is called, it is also known as boron sesquioxide. You remember B2O3, N2O3, P2O3, Al2O3. So the ratio is 2:3 ratio or 1:1.5 ratio. This type of oxide ledunna, but nevamantavanante sesquioxide antaru. So boron sesqui, aluminum sesqui, nitrogen sesqui, and phosphorus sesqui. Sesqui means 2:3 or 1:1.5 ratio. So the boron oxide is a boron called also
Sir,
called
repeat once.
boron sesquioxide. Yes.
Sir, once repeat చేయండి sir.
Right. ఒక్కసారి చెప్తా. Very important point ఇది. For example, any oxides like carbon oxide, nitrogen oxide, phosphorus oxide, any oxide, 2:3 ratio ఉందనుకోండి. B2O3 ఇక్కడ చూడండి. Remember B2O3 2:3, Al2O3, N2O3, P2O3 అంటే 2:3 అనే రేషియో కనుక ఉంటే ఆ ఆక్సైడ్ అన్నిటిని ఏమంటున్నానంటే సెస్క్వి ఆక్సైడ్. అది బోరాన్ అయితే బోరాన్ సెస్క్వి, నైట్రోజన్ అయితే నైట్రోజన్ సెస్క్వి, ఫాస్ఫరస్ సెస్క్వి, అల్యూమినియం సెస్క్వి. సెస్క్వి మీన్స్ 2:3 రేషియో ఆఫ్ ఆటమ్స్. ఓకే, ఇది ఒక రిమెంబర్ గుర్తుపెట్టు. ఇక్కడ మనకు లక్కీలీ boron B2O3 is a sesqui oxide అంటారు. So how can you prepare in the laboratory? The starting material is orthoboric acid, H3BO3. Heating at 100 degrees centigrade, metaboric acid. And again heating 160, tetraboric acid. Again heating through red hot copper tube, you are getting B2O3. So ఇక్కడ మీరు గుర్తుపెట్టుకోండి, ఎగ్జాంపుల్ ఏమవుతున్నానంటే బోరిక్ యాసిడ్ ను హీట్ చేస్తే బోరాన్ ట్రైఆక్సైడ్ వస్తుంది. ఈ రియాక్షన్ లో వాట్ ఆర్ ద ఇంటర్మీడియేట్స్? వీటిని అడుగుతుంటాడు క్వశ్చన్. అంటే ఆర్థోబోరిక్ యాసిడ్ ను బాగా హీట్ చేస్తే యూఆర్ గెటింగ్ బోరాన్ ట్రైఆక్సైడ్. But the intermediate compounds are two. One is metaboric acid, the second one is tetraboric acid. ఈ రెండు కూడా గుర్తుపెట్టుకోవాలి. So starting, ending important along with middle one. So the intermediate compounds also we are expecting. So metaboric acid formula, tetraboric acid formula important. So boric acid heat చేస్తే final compound B2O3 తో పాటు we are also getting metaboric acid and tetraboric acid also. This is also important. So this is the preparation of B2O3. You come to borax. So Na2B for borax, ఎలా ఫామ్ అవుతుంది? You take boric acid, react with the sodium carbonate, you are getting sodium tetraborate, is called borax. ఈ borate sodium tetraborate కి for example 5 moles of water యాడ్ చేస్తే that is called octahedral borax, jewelry borax అంటారు. దీనికి 10 moles of water యాడ్ చేస్తే that is called ordinary borax, prismatic borax and monoclinic borax అంటారు. Without water ఉందనుకోండి, that is called anhydrous borax. So the borax generally classified into 3 types. So jewelry, ordinary, anhydrous. So with 5 moles, with 10 moles, without water. So types of borax. 3 names కూడా మనకు అప్పుడప్పుడు అడుగుతుంటాడు. Which of the following is a jewelry borax? And which of the following is a prismatic borax? Which of the following is a anhydrous borax? And antaడు formulas. So you remember the borax general formula Na2B4O7, including with 5 water, 10 water, without water. అనేది 3 names ఉంటాయి. So you remember 3 names. And borax is heated in a Bunsen burner flame with metal oxide on a loop of platinum wire. The mixture fuses to give a glass-like metaborate bead. ఇది ఒక చాలా ఇంపార్టెంట్ నాన్న. టెట్రాబోరిక్ బోరాక్స్ కనుక హీట్ కనుక చేస్తే ఏ ట్రాన్స్పరెంట్ గ్లాస్ బీడ్ ఇలా ఫామ్ అవుతుంది. ఆ గ్లాస్ బీడ్ లో ఫార్ములా B2O3 and sodium metaborate. A unknown transition metal oxide is added to a transparent glassy bead, followed by heating. The respective metallic borate is produced, exhibiting a specific color. Based on its specific color, it can be detected. So, for example, B2O3 lo copper oxide mix cheste we are getting blue color vastundi, and B2O3 ki cobalt oxide kanaka add cheste blue color, and boron chromium తీసుకుంటే green color. ఇలా different colors and మనకి exhibit చేస్తారు. That is called borax bead test అంటారు. That is also important. Sometime we are expecting an interest point of view. And another property is after hydrate and oxide, you go to the third property is halide. So ఇందాక మీకు చెప్పాను halides means the group element to react with the halogen gives halides అన్నాను. You take first boron. The boron react with halogens gives boron trihalides. The general formula is BX3. X means halogen, BX3. Examples BF3, BCl3, BBr3, Bi3. So ఇక్కడ ఎగ్జాంపుల్ ఏంటంటే వెరీ ఇంపార్టెంట్ పాయింట్ ఏదైనా అంటే ఆల్ బోరాన్ హాలైడ్స్. యూ రిమెంబర్ వెరీ 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 ఇంపార్టెంట్ ఇన్ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ ఎంట్రన్స్ లో. కంపల్సరీ ఐఎమ్ ఎక్స్పెక్టింగ్ ద క్వశ్చన్ ఫ్రమ్ దిస్ ఏరియా. సో boron halides, all boron halides, trihalides are act as a Lewis acid. అన్ని కూడా లూయిస్ యాసిడ్లే, ఎందుకంటే ఎలక్ట్రాన్ డెఫిషియన్సీ ఉంది. యూ రిమెంబర్, యూ సీ boron valence electrons are 3. The chlorines sharing with the 3 bond, only 6 electrons are around boron, but for going to octet configuration we required another 2 electrons. 2 electron deficiency ఉంది కాబట్టి all boron halides are acting as a Lewis acids. You remember, all are Lewis acid. ఎందుకంటే ఎలక్ట్రాన్ డెఫిషియన్సీ ఉంది. ఎంత డెఫిషియన్సీ ఉంది? 2 electron deficiency ఉంది అన్నిట్లో. సో అకార్డింగ్ టు ఎలక్ట్రోనెగటివిటీ, BF3 is act as a strong Lewis acid. According to electronegativity rules ప్రకారం BF3 ఉండాలి. But due to forming the strong back bonding అనే కొత్త వర్డ్ వచ్చింది ఇక్కడ, back bonding between boron and fluorine atom, the electron deficiency over on boron atom. Therefore, ultimately the order of Lewis acid character, actual మన అందరూ BF3 అనుకున్నాం, కాదు, which is PBr3 is a strongest Lewis acid than BCl3, BF3, Bi3. So ultimately PBr3 exhibiting more Lewis acid character. Actually మనం ఏమనుకుంటున్నాం, అందరం హైలీ ఎలక్ట్రోనెగటివిటీ కాబట్టి BF3 అనుకున్నాం, బట్ theoretically BF3, but experimentally PBr3 goes first one. So this is the right order character order of boron trihalides. So you see this is the explanation, right? All of you see here, this is back bond, this is BF3. So boron and fluorine having same p orbital, same size orbitals, and this is boron p orbital. This is chlorine atomic size more compared to boron, the size also increased here. Bromine size inka పెరుగుతుంది. So iodine size inka because the iodine atomic number more. But boron size is almost the same, equal in their distance lo unnai. So this is the flow halogen p orbitals filled with full electrons, like this electrons fill అయిపోయినాయి. And boron or electron deficiency కాబట్టి empty orbitals la పెట్టారు. ఇక్కడ చూడండి, due to back bond. You remember, boron size, fluorine size, orbital p orbital size almost same కాబట్టి cent% ఇక్కడ నుంచి ట్రాన్స్ఫర్ అయ్యి బోరాన్ కు షిఫ్ట్ అవుతుంది. కాబట్టి ఎలక్ట్రాన్ డెఫిషియన్సీ boron లో క్లియర్ అవుతుంది, సాటిస్ఫై అవుతుంది, బికాస్ the boron phosphorus both p orbitals size almost same. Therefore, cent% p orbital shift moving towards boron side. Ultimately, the boron satisfied. So the deficiency is nil. It is a satisfied. Leave it. So according to back bond, the boron is satisfied in BF3. Okay, ఇది ఇప్పుడు లూయిస్ యాసిడ్ క్యారెక్టర్ లేదు, ఇది డెఫిషియన్సీ క్లియర్ అయిపోయింది. You come to here. You చూడండి సైజ్ డిఫరెన్స్ ఉంది. సో 100% షిఫ్ట్ కాలేదు, సైజ్ ఇంక ఇలానే ఎక్కువ సైజ్ ఉంది. ఓకే, సో ఇందులో రిమైనింగ్ కొంత డెఫిషియన్సీ ఉంది. యూ కమ్ టు ఇయర్, ఇది ఇంకా బిగ్ సైజ్ లో ఉంది, కొంతవరకు షిఫ్ట్ అయింది, ఇంకా డెఫిషియన్సీ ఉంది. మరి ఈ సైజ్ ఇంకా ఎక్కువ ఉంది, బట్ ఇది యాక్చువల్ ఆన్సర్ ఇదే ఉండాలి. రీజన్ ఈజ్ ద అయోడిన్ ఈజ్ ఏ అన్స్టేబుల్ బిగ్ సైజ్, బోరాన్ ఈజ్ ఏ స్మాల్, అయోడిన్ ఈజ్ ఏ బిగ్ సైజ్, బట్ డ్యూ టు స్టెబిలిటీ ద బాండ్ ఇక్కడ బ్రేక్ అవుతుంది, అయోడిన్ షిఫ్ట్ అయిపోయి I2 గా ఫామ్ అవుతుంది, అంటే స్టేబుల్ మాలిక్యూల్ కాదు. సో దీస్ 3 ఆర్ ద స్టేబుల్. ఈ స్టెబిలిటీలో స్టేబుల్ మాలిక్యూల్ లో దిస్ వన్ ఈజ్ మోర్ ఎలక్ట్రాన్ డెఫిషియన్సీ మాలిక్యూల్. సో దట్స్ వై దిస్ ఈస్ ద ఆర్డర్. This is the order. BBr3 is the more Lewis acid character, exhibiting Lewis acid character than BCl3, BF3. So this is actually the answer undali, but due to oversize between boron and iodine always going to I2 form. So that's why dissociate out bond break out kabatti leave it about. The comparatively 3, this one is more Lewis acid character. This is the right sequence order, right? The bond is called back bond. That now you remember strong back bond between boron and halogens. So the BBr3 exhibiting more Lewis acid character. So this is the halogens properties. And now come to oxy acid, the last chemical property in third A. First hydrates completed and oxides completed, and third one is halides completed. The fourth one is oxy acids of boron. Now, just now I told you the metaboric acid, and these two are the most important. This one is the most important, boric acid. We have to using in the carom board, boric powder. This is called boric acid structure H3BO3. And preparations and properties not important. And this is, remember, the boric acid, metaboric acid preparation and boric acid preparation. And this is the structure. And you see in textbook the structure of boric acid, etc. Now come to fourth A. Same process. So from third year lo cover chesam hydrate, halide, oxide, oxy acid. The same tempo you maintain in fourth year also. అందుకని ఒక్క గ్రూప్ కనుక మీరు పర్ఫెక్ట్ రీడ్ చేస్తే, ఒక గ్రూప్ లో కనుక ఈ ప్రాపర్టీస్ కనుక క్లారిటీగా అవుతే అప్ టు 8th వరకు ఇదే సీక్వెన్స్ లో వెళ్ళిపోవచ్చు. సో అందుకని ఇనార్గానిక్ కెమిస్ట్రీ అంటే పిల్లలందరికీ ఏమంటారు, చాలా బోర్గా వస్తుంది. అంటే ఐ మీన్ చాలా హెడేక్, సమ్ బోర్ వస్తుంది. నో డోంట్ ఫీల్ లైక్ దట్. సో వన్స్ ఒక్కసారి మీరు ప్రాపర్ కనుక రీడ్ చేసి ఒక సీక్వెన్స్ కనుక మీరు ప్లాన్ చేసుకుని, ఇందాక నేను చెప్పాను ఫిజికల్ ప్రాపర్టీస్ అండ్ కెమికల్ ప్రాపర్టీ. కెమికల్ ప్రాపర్టీలో 4 ప్రాపర్టీస్. 4 ప్రాపర్టీలో ఫస్ట్ హైడ్రేట్ ప్రాపర్టీ, అండ్ సెకండ్ వన్ ఆక్సైడ్ ప్రాపర్టీ, థర్డ్ వన్ హాలైడ్ ప్రాపర్టీ, ఫోర్త్ వన్ ఆక్సీ యాసిడ్. ఈ సీక్వెన్స్ లో ఈచ్ గ్రూప్ కనుక మనం ప్రాపర్టీ డిస్కస్ చేసుకుంటూ వెళ్తే అప్పుడు మీకు ఈజీగా అండర్స్టాండ్ అవుతుంది. సో వన్స్ ఒక్కసారి మీరు క్యాచ్ చేశారనుకోండి, సో ఈ లెసన్ చాలా అండర్స్టాండ్ కనుక అవుతే యూ విల్ గెట్ అరౌండ్ 10 marks in entrance point of view. So not a joke. సింగిల్ మార్క్ లో చాలా మంది ర్యాంక్ లో ఓవర్కమ్ అవుతుంటారు. ఒక సింగిల్ మార్క్ మీకు డిఫరెన్స్ వచ్చిందంటే మీ పైన 1000 మెంబర్స్ జంప్ అవుతుంటారు. ఎంట్రన్స్ కి ఎగ్జామినేషన్ తేడా అదే. ఎగ్జామినేషన్ లో మీరు నార్మల్ థియరీ ఎగ్జామ్, సెమిస్టర్ ఎగ్జామ్స్ రాస్తున్నప్పుడు ఒక క్వశ్చన్ అటెంప్ట్ చేయకుండా నో ఇష్యూ, ఒక 5 marks మీకు లెస్ అవుతాయి, 10 marks లెస్ అవుతాయి, నో ఇష్యూ. బట్ యూ కమ్ టు ఎంట్రన్స్ పాయింట్ ఆఫ్ వ్యూ, ఒక సింగిల్ క్వశ్చన్ నెగ్లెక్ట్ మీరు చేశారనుకోండి, మీ మీద 1000 మెంబర్స్ ముందుకు వచ్చేస్తారు. సో ఎవ్రీ క్వశ్చన్ 4 ఆప్షన్స్ మీరు అటెంప్ట్ చేసేటప్పుడు బీ కేర్ఫుల్. ఆ 90 minutes మీ ఫోకస్ ఆన్ క్వశ్చన్ పేపర్ మీదనే ఉండాలి. క్వశ్చన్ రీడ్ చేసుకోవాలి, ఆప్షన్స్ 4 ఆప్షన్స్ క్లియర్గా అబ్జర్వ్ చేయాలి. ఆడ్ మ్యాన్ అవుట్, ఆన్సర్ ఏ కాదు, బి కాదు, సిడిలలో ఏది కరెక్ట్ ఒకసారి థింక్ చేసి ఆన్ పేపర్ మీద ప్రాక్టీస్ చేసి ఆప్షన్ సీనా డీనా. ఈ స్టైల్లో ఈచ్ క్వశ్చన్ మీరు టచ్ చేసుకుంటూ పోతేనే యూ విల్ గెట్ మోర్ మార్క్స్. అవుట్ ఆఫ్ 100 అరౌండ్ 70 to 80 మనం స్కోర్ చేయాలి. 70 to 80 స్కోర్ చేస్తేనే, అది మినిమం, డిపెండ్స్ అపాన్ పేపర్ స్టాండర్డ్. ఆ స్టాండర్డ్ పెట్టి టఫ్ ఉంటుందా, మీడియం ఉంటుందా, ఈజీగా ఉంటుందా, డిపెండ్స్ అపాన్. బట్ ఎనీ పేపర్ యూ రిమెంబర్, అవుట్ ఆఫ్ 100 marks క్వశ్చన్స్ లో ఫర్ ఎగ్జాంపుల్ 30 questions నార్మల్గా ఉంటాయి, కామన్ మ్యాన్. యావరేజ్ క్వశ్చన్స్ ఎవరైనా అటెంప్ట్ చేయొచ్చు, 30 questions. సో రిమైనింగ్ 30 questions, 40 questions మీడియం ఉంటాయి, ఒక రేంజ్ ప్రిపేర్ అయిన వాడే అటెంప్ట్ చేస్తారు. సో 30 + 40 70 ఈజ్ కామన్. బట్ ద లాస్ట్ 30 questions వెరీ వెరీ ఇంపార్టెంట్. 30 questions ఓన్లీ హార్డ్ వర్క్ చేసిన వాళ్ళే, ఎవరైతే తరోగా ప్రిపేర్ అయిన వాళ్ళే ఎవరైతే సిలబస్ ముందు పెట్టుకొని యూనివర్సిటీ వాళ్ళు రిలీజ్ చేసిన నోటిఫికేషన్లో రిలీజ్ చేసిన సిలబస్ ముందు పెట్టుకొని పాయింట్ టు పాయింట్ ఇనర్ట్ ఫేర్ ఎఫెక్ట్ అని ఒక వర్డ్ ఉందనుకోండి, దాని మీద క్లియర్గా అలోట్రోపీ క్లియర్గా, ఓకే, బ్యాక్ బాండ్ క్లియర్గా, ఇవన్నీ మీరు ప్రిపేర్ అయిన వాడే ఆ రిమైనింగ్ 30 అటెంప్ట్ చేస్తుంటాడు. సో ఫస్ట్ 30 ఎవరైనా చేస్తారు, రిమైనింగ్ 40 అబౌవ్, ఇంకా నెక్స్ట్ 40 ఒక రేంజ్లో ప్రిపేర్ వాడు చేస్తాడు. ఇక లాస్ట్ 30 క్వశ్చన్స్ అనేది ఎవరైతే హెవీ హార్డ్ వర్క్ చేస్తారో ఒక 30 days వాళ్ళు మాత్రమే 30 చేస్తారు. అందుకని 70 + 30 100, అంటే 70 కామన్, ఎబోవ్ ఒక్కొక్క మార్క్ ఇంప్రూవ్ అయిన కొద్దీ మీ స్కోర్ ఎక్కడికో టాప్కి వెళ్ళిపోతుంటారు. కాబట్టి డియర్ స్టూడెంట్స్, యూ రీడ్ ప్రాపర్లీ, కరెక్ట్ ప్లాన్ చేసుకోండి. మీరు ఊరికి ఏదో టైంపాస్కి ప్రిపేర్ కాకుండా ఫస్ట్ యూ సీ ద సిలబస్. ఆ సిలబస్ కాబట్టి ప్రింట్ తీసుకోండి, మీ దగ్గర మీ ప్యాడ్ మీద పెట్టుకొని స్టిక్ ఆన్ చేయండి దాన్ని. ఎవ్రీడే ఆ సిలబస్ రీడ్ చేసుకుంటూ బుల్లెట్ పాయింట్స్లో టిక్ చేసుకుంటూ ఓ వైట్ పేపర్ తీసుకొని దాంట్లో ప్రాక్టీస్ చేసుకుంటూ డైలీ సిలబస్ ఇన్ఆర్గానిక్ చాప్టర్స్, ఆర్గానిక్ చాప్టర్స్, ఫిజికల్ చాప్టర్స్, స్పెక్ట్రోస్కోపీ చాప్టర్స్ డివైడ్ చేసుకుంటూ ఎన్ని చాప్టర్స్ కవర్ చేశానని టిక్ చేసుకుంటూ కనుక ప్లాన్ చేసుకుంటే మీరు ప్రాపర్గా ప్రిపరేషన్ అవుతేనే ఈ స్కోర్ అనేది ఉంటుంది. సో సెంట్రల్ యూనివర్సిటీలో మీకు రావాలి, ఉస్మానియా క్యాంపస్లో రావాలి అంటే క్యాంపస్ వేరు, పీజీ సెంటర్స్ వేరు, ప్రైవేట్ కాలేజ్ డిఫరెంట్. సో వీ వాంట్ ఓన్లీ క్యాంపస్ ఫ్రీ సీట్స్, యూ డోంట్ వాంట్ ప్రైవేట్ సీట్స్ అండ్ యూ డోంట్ వాంట్ పేమెంట్ సీట్స్. సో దట్ ఈస్ అవర్ మోటో. సో ఆ మోటో మనకు రావాలి అంటే, ఆ లెవెల్ కావాలి అంటే థరోలీ రీడ్ ఈచ్ కార్నర్. ఏ ఒక్కటి నెగ్లెక్ట్ చేయాలి. ఇన్ఆర్గానిక్ కెమిస్ట్రీ ఎంత ఇంపార్టెన్స్ ఇస్తావో యూ గో టు సేమ్ ఇంపార్టెన్స్ ఆర్గానిక్ కెమిస్ట్రీ అండ్ ఫిజికల్ అండ్ స్పెక్ట్రల్. సో ఈచ్ చాప్టర్ మీ మైండ్లో ఉండాలి, బేసిక్ ఉండాలి, కొంచెం డెప్త్ ఉండాలి, రిలవెంట్ ఎగ్జాంపుల్స్ మీ దగ్గర ఉండాలి. ఇలా చాప్టర్ మన సార్స్ ఇచ్చాను అందరి గైడెన్స్ కనుక తీసుకొని కరెక్ట్ మీరు ఒక 20 days ప్లాన్ చేస్తే డెఫినెట్లీ మీరు సక్సెస్ కావడానికి స్కోప్ ఉంటుంది. నో డౌట్ అట్ ఆల్. ఖచ్చితంగా మీ క్యాంపస్లో ఫ్రీ సీట్ వస్తుంది. సో ఫ్రీ ఆఫ్ కాస్ట్, దట్ ఈస్ అవర్ ఇంపార్టెంట్. అంతేగాని డొనేషన్లో పేమెంట్ సీట్లో కొంటామంటే దట్ ఈస్ రాంగ్. సో మనకు బ్రెయిన్ ఉంది, ప్రాపర్గా కూర్చుందాం, గైడెన్స్ ఉంది, మంచి ఫ్యాకల్టీ మీకు అవైలబుల్ ఉన్నారు, డైలీ మీకు సార్స్ ఒక్కొక్క డిఫరెంట్ ఫ్యాకల్టీ మీకు గైడెన్స్ ఇస్తున్నారు. అందరు గైడెన్స్ మీరు కలెక్ట్ చేసుకొని మీరు ప్రాపర్గా కూర్చుకుంటే ఖచ్చితంగా మీరు సక్సెస్ కావడానికి స్కోప్ ఉంటుంది. ఓకే, దిస్ ఇస్ మై అడ్వైస్. అండ్ నౌ కమ్ టు ద నెక్స్ట్ లెసన్. జస్ట్ ఇక్కడ నుంచి స్పీడ్ అయిపోతుంది, జస్ట్ ఇంట్రడక్షన్ వరకు లేట్ అయింది. నెక్స్ట్ 1 by 1 మీకు ఐడియా ఉంది కాబట్టి స్పీడప్ చేస్తుంటాను. యూ కమ్ టు 4th year, మీకు ఒక తర్వాత బ్రేక్ ఇస్తాను. 4th year. సో దీస్ ఆర్ ద యూ సీ ద గ్రూప్ ఎలిమెంట్స్ 4th year. యు నో ద కార్బన్, సిలికాన్, జెర్మేనియం, టిన్, lead మీకు తెలిసిందే. The common electron configuration, you know, ns2 np2, why? Because 4 valence electrons are there here. So 2s2 2p2, like ns2 np2 electron configuration. And these are the physical and chemical. Me this already. Just now I told you, MPT, BPT, one character, and metallic nature, and allotrophy, and OS, and chemical property మీకు చెప్పిన already. Hydrates, halides, oxides. వీటితో పాటు along with some special properties also there. They are very, very important properties in 4th year, that is called carbide, silicones, silicates, and carbonyls. Okay, comes under special properties in 4th year group elements. ఇవన్నీ వచ్చేసాయి, ఇక్కడ కొత్తగా యాడ్ అయినాయి కార్బైడ్స్, సిలికోన్స్, సిలికేట్స్ అండ్ కార్బోనైల్స్. ఇవి మనకు నేనేమంటున్నాను అంటే, మీరు యాజ్ ఏ స్టూడెంట్గా మీరు రేపు ఫ్యూచర్లో రేపు ప్రిపేర్ అయ్యేటప్పుడు ఈ ఏరియా, నేను చెప్పిన ఏరియా స్లైడ్ మొత్తం మీ మైండ్లో ఉండాలి. 4th గ్రూప్ అనే టైటిల్ ఉంటే ఇవన్నీ కవర్ చేయాలి. ఇందులో అలోట్రోపీ అనగానే మీరు ఆన్సర్ ఇవ్వాలి, ఓఎస్ ఆన్సర్ రావాలి, హైడ్రేట్స్ ఆఫ్ 4th అంటే మీ దగ్గర ఇమేజ్ రావాలి, మీకు స్ట్రక్చర్ రావాలి మీ మైండ్లో. ఆక్సైడ్స్ ఆఫ్ 4th అనగానే మీ ఆక్సైడ్స్ అన్ని మీకు లిస్ట్ మీ మైండ్లో రావాలి. కార్బైడ్స్ డెఫినేషన్ రావాలి, టైప్స్ రావాలి, సిలికాన్ డెఫినేషన్ అండ్ టైప్స్, సిలికేట్స్ డెఫినేషన్ అండ్ టైప్స్, కార్బోనైల్ డెఫినేషన్ అండ్ టైప్స్. ఇదంతా మీ మైండ్లో ఉంటేనే మీ ప్రిపరేషన్ త్వరగా ఉంటుంది. ఇది వెరీ సింపుల్, పాసిబుల్, నో ఇష్యూ. ఇది టఫ్ ఏం కాదు. మీరు కరెక్ట్గా కూర్చుంటే ఒక 10-15 daysలో మీరు ఇన్ఆర్గానిక్లో జమ్ అయిపోతుంటారు, నో ఇష్యూ. నౌ కమ్ టు దిస్ ఇస్ ఫిజికల్ ప్రాపర్టీ. ఇక్కడ నాట్ ఇంపార్టెంట్ ఫర్ ఎగ్జామినేషన్, జస్ట్ మీకు చూపిస్తున్నాను. ఇక్కడ ఒక పాయింట్ డిఫరెన్స్ ఇక్కడ మీరు అబ్జర్వ్ చేయండి. ఈ కోవలెంట్ రేడియస్, అయనేషన్ పడి లిమిట్ అబౌట్ దిర్ ఆల్ వాల్యూస్, మీకు ఏం అవసరం లేదు. బట్ యు కమ్ టు యు ఫోకస్ ఆన్ MPT. చూడండి ఇక్కడ C, the value 4100. You remember why the carbon exhibiting highest melting point, right? You come to Pauling scale value, highest electronegativity C 2.5. ఇవన్నీ మనకు అవసరం లేదు లిమిట్, ఇవన్నీ మనకి ఇప్పుడు టైం లేదు మనం ప్రిపేర్ కావడానికి. యూ ఫోకస్ ఆన్ melting point. The why the carbon exhibiting highest melting point means, just now I told you, the carbon allotropes, diamond, the diamond exhibiting highest oddest substances in the earth. So manaku earth crust available lo oddest substance nanante diamond. So the diamond melt cheyadaniki how much temperature we have required here? 4100 degrees centigrade for going to just solid to liquid. So in the temperature మనం ప్రొవైడ్ చేయలేం కాబట్టి the diamond always a stable form. So hardest substance అంటే diamond. So the carbon exhibiting highest electronegativity 2.5 values. Now this is the carbon allotrope form of carbon. This is called diamond, right? The crystal structure of a diamond like this. This is the structure of a diamond. The carbon along with the 4 carbons, like tetrahedral structural form in this is the carbon strong sigma bonds ఉంటాయి. Around carbon 4 strong sigma bond break చేయాలంటే we have to provide more energy, right? This is the graphite. In that we said it is layered structure, layer 1, layer 2, layer hexagonal rings ఇలా ఉంటాయి. Okay, right? Now this is a Fullerene structure. The Buckminster football shape ఉంటుంది. This is C60 or C120 or 180 carbons are associated here. The modern Buckminster Fullerenes. ఒక్కొక్క Fullerene లో కొన్నిసార్లు 60 carbons, 120 carbons ఉంటాయి. So this is Fullerene structure. These 3 are that comes under crystalline allotropes of carbon. Okay, carbon యొక్క allotropes లో ఇవన్నీ types. The next one is oxides. Oxides. Okay, oxides. So very important property here. You see, for example, the 4th year group element. You see, all of you see here. The 4th year group element react with oxygen gives MO2 formula of oxide. Why MO2 form of oxide? Why not MO3? Anyone? Can you explain about why the 4th year group elements form only MO2 oxides, not MO3, MO4? Why? What is the reason? Why the 4th year group elements can always form only MO2 type of oxides, not MO3 or MO4? What is the reason?
+4 oxidation ఉంటాయి sir.
Yes. Why? Because the 4th maximum covalency is a +4. That's why the MO2 or +4. So MO2 in place of M, you have to substitute carbon CO2, SiO2, GeO2, SnO2, PbO. Now you see here, all are +4 oxidation state, but in case of lead, the lead exhibiting only +2 due to inert wear effect. So due to inert wear effect, the lead exhibiting only +2 oxidation state, that's why PbO. But the remaining all elements can form MO2 type of oxides, CO2 like this. But in case of carbon, the carbon exhibit another 2 oxides also. One is CO, C3O2. Total 3 oxides. This is carbon monoxide, carbon dioxide. This is called carbon. Anyone? Can you tell me the name? C3O2 name is? This is a carbon monoxide, and this is carbon dioxide, and this one? In pair delsa, any idea about this compound name? This is carbon suboxide, carbon monoxide, carbon dioxide, carbon suboxide. Sub means less oxygen. This is called carbon suboxide. Right. Sub, SUB, sub. Right. Now you see the most important is carbon monoxide structure. So this is formic acid. On with sulfuric acid, you are getting CO. Limit about preparation, not important for examination point of view. The structure is most important. In CO, the carbon ground state 1s2, 2s2, 2p2. Right? This is electron configuration, electrons distribution from s orbital containing 2, and this is px, py. Right? In the ground state, one s orbital, one p orbital combined together to form sp hybridization. This is sp hybridization. So one sigma, one lone pair, and the another one is form 5 bond. So now this is the structure. All of you see here. This is CO. This CO, right? The lone pair oxygen moving towards the carbon side. This is a triple bond present here, and but the carbon having also one pair, and this is also ready to donating a pair of electron. That's why the carbon monoxide acting as a best ligand. You know what is the meaning of ligand? Ligand means donating a pair of electron towards the metal side. So that's the CO acting as a good ligand because this is the lone pair. The CO containing one sigma, 2 pi. 2 pi. This is a day2 bond, this is sigma bond. And the hybridization is sp, geometry is linear. The sp, when it is in ground state, in the ground state, the CO, the carbon exhibiting sp hybridization. But you come to CO2, like this is CO2 structure, the carbon, excited state, and one s orbital, one p orbital combined sp. The remaining lone pair, 2 unpaired electrons form pi bonds. The total bonds are 4, 2 sigma 2 pi, right? 2 sigma 2 pi bonds, and CO2 structure like this, right? And here also sp hybridization but excited state, and before molecule sp hybridization but ground state. And these are the difference between CO and CO2. And C3O2 structure like this, linear structure, and each carbon shows sp hybridization. And like these are the sp, right? The structure. And now silicon dioxide structure, SiO2, silicon, it is a 3-dimensional polymerization structure, it is a polymeric structure, and each sulfur containing 4 sigma bonds like this. Alternative silicon, silicon alternative bonds are there. Each sulfur, silicon exhibiting sp3 hybridization, and these are the structure of Si. And now the oxy acids of carbon, the carbon oxy acid is called H2CO3. The CO2 when dissolved in water, they create H2CO3. This is H2CO3 structure. This is called carbonic acid. And the next one, special property, carbonyls. And this is a carbonyl. And nickel tetracarbonyl, iron pentacarbonyl, ruthenium pentacarbonyl, chromium hexacarbonyl like this. The nickel tetracarbonyl preparation like this. The any metal directly react with the carbon monoxide gives carbonyls. And this is structure, metal ligand bond. You see all of you. And this is the lone pair electrons mutually sharing, metal donating to ligand side and ligand also donating towards metal side. So one sigma, one pi bond present here. This is the structural information, the nickel carbonyl structure. And this is structure of penta, diiron nonacarbonyl, Fe2CO9. You see, this is bridge bond. These are the terminal bonds. 3 plus 3, 6 terminal bonds, 3 bridge bonds, FeCO, Fe. And this is the structure of Fe2CO9. And the next one, another one important one is carbides. So compounds of carbon with more or less electronegative elements are known as carbides. The carbides are basically 4 types. You see, one is ionic carbide, and second one covalent carbide, and interstitial carbide are iron type of carbide. I am expecting one question from ionic carbide or covalent carbide in entrance point of view. So carbides means, you remember, the compound of carbon with more or less electronegative element are known as carbides. Carbides are basically 4 types. The first one is ionic carbide. The ionic carbide again classified into 3. So 3 examples divided here. Ionic carbide, methanamide, acetylide, allylide. Example Al4C3, beryllium Bu2C. Compounds is called methanamide carbides antar. Enduku nana ante the Al4C3 or Bu2C when dissolved in water, they produced methane gas. So Al4C3 plus water gives methane. Bu2C plus water gives methane. So ఈ రెండు methane gas produce చేస్తున్నాయి కాబట్టి they are methanamide. So these 2 compounds, calcium carbide, when dissolved in water, they produced acetylene. That's why these carbide are called acetylide carbide. So Mg2, CaC2. Suppose you take Mg2C3, magnesium carbide, when dissolved in water, allylene. That's why the carbide is called carbide. So, dear student, you remember the 3 names: methanamide example, acetylide carbide example, allyl carbide example. ఏమంటాడు example అంటే question, which of the following is a methanamide carbide? Which of the following is a acetylide carbide? Which of the following is a allyl carbide? ఇవి model questions. కాబట్టి remember, name with example important. CAl4C3, E2C is these two are the best example for methanamide, because these two oxides, when dissolved in water, they produced methane gas. That is important. And the next one, covalent carbide. So in the CCl4, CH4 is a normal, but the polymeric type of carbide, covalent carbides are very, very important here. Silicon carbide, SiC. Generally we call carborandum, silicon carbide, SiC. And B4C, very boron carbide and boron carbide. These three examples for polymeric type of covalent carbides. And interstitial carbides, this is a tantalum, wolframite, and a tungsten. A tungsten metal molecules middle low and crystal structures low carbon intermix out. That's why the type of carbides are called interstitial carbides or metallide carbides. So out of three low, the first one is most important. So one time, silicon carbide is the best example. The silicon carbide is a covalent carbide of carbides. And remaining three carbides, these three are the most important in entrance point of view. And the next one, silicones. Silicone is the organosilicon polymers containing SiO-Si bonds are known as silicones. అంటే ఆ మాలిక్యూల్ ఏమన్నా సిలికాన్ ఓ సిలికాన్ రిపీటెడ్ యూనిట్ ఉండాలి. దిస్ టైప్ ఆఫ్ మాలిక్యూల్ కనుకుంటే దట్ కాంపౌండ్స్ ఆర్ సిలిక్, ఇట్స్ అ పాలిమరిక్ కాంపౌండ్స్. దీస్ ఆర్ టైప్ చైన్ సిలికోన్స్ అండ్ సైక్లిక్ సిలికోన్స్ అండ్ క్రాస్ లింక్ సిలికోన్స్. ఇందులో వాడు అడిగేది క్వశ్చన్ ఏంటంటే అంటే చైన్ సిలికోన్స్ ఫామ్ కావాలంటే స్టార్టింగ్ మెటీరియల్ ఏంటంటాడు. సో డైమిథైల్ డైక్లోరోసిలేన్ is the starting material for chain silicones. Dimethyl dichlorosilane is the starting material for cyclic silicones, and methyl trichlorosilane is the starting material for cross-linked silicones అంటారు. సో స్టార్టింగ్ మెటీరియల్ మీద మన క్వశ్చన్ అడుగుతున్నాడు కాబట్టి దిస్ ఇస్ ద ప్రిపరేషన్ ఆఫ్ చైన్ సిలికోన్. యు సీ ద స్టార్టింగ్ మెటీరియల్ డయాల్ డైక్లోరోసిలేన్ treated with water, dihydroxy dialkyl silicone, and remove water, ఈ కాంపౌండ్ ఫామ్ అవుతుంది. యు టేక్ డైహైడ్రాక్సీ డయాల్కైల్ సిలికాన్ 2 మాలిక్యూల్ తీసుకుంటున్నాను, హీట్ చేశాను, రిమూవ్ అవుతుంది. యు ఆర్ గెటింగ్ చైన్ సిలికాన్. చూడండి, డైఆల్కైల్ సిలికాన్ ఓ సిలికా ఈజ్ ఎ రిపీటెడ్ యూనిట్. ఇక్కడ చూడండి, నెక్స్ట్ థర్డ్ మాలిక్యూల్ ఇచ్చాను, 3 మాలిక్యూల్స్ ఫామ్ అయినాయి. ఎవ్రీ మాలిక్యూల్ సేమ్ ఉంటుంది. డయాల్కైల్ సిలికాన్ ఆక్సైడ్ సిలికాన్, dialkyl silicon oxide silicon is a repeated unit. This type of containing molecules are called silicones. So ivanni kuda silicones kinda antav. This is called chain silicones. Okay, these are chain silicone. Two more. This is the thermal line. Trimethyl hydroxy silicone iskunna. This is hexamethyl disiloxide, and this is also cyclic silicones. 3 molecules cyclic silicones, 3 molecules. And 4 molecules there. So next, silicate. The compounds containing SiO4-4 units are known as silicates. The silicates are 4 types here: orthosilicate, pyrosilicate, sheet silicate, cyclic silicate, 3-dimensional silicate. So దీంట్లో మాలిక్యూల్ ఫార్మ్ ఏముంటున్నారంటే SiO4-4. ఈ స్ట్రక్చర్ మీకు చూపిస్తాను చూడండి. SiO4 around the silicon 4 oxygens are there. The charge is -4 ఉంటుంది. ఈ యూనిట్స్ కనుక ఉంటే దట్ ఇస్ కాల్డ్ కామన్ కంటైనింగ్ దిస్ యూనిట్. ఆర్థోసిలికేట్ జనరల్ ఫామ్ లో ఓన్లీ 1 యూనిట్ ఉంటుంది. ఇలాంటి 2 యూనిట్స్ కనుకుంటే దట్ ఇస్ కాల్డ్ పైరోసిలికేట్. మోర్ దాన్ కనుకుంటే షీట్ అండ్ సైక్లిక్ సిలికేట్స్ అంటారు. సో దిస్ ఇస్ ద జనరల్ ఫార్ములా. యు సీ ఆర్థోసిలికేట్ అరౌండ్ సిలికాన్ 4 oxygens are there. Each oxygen containing -1 charge. SiO4-4. This is thickness is called, thick circle is called silicon, and normal circle is called oxygen, and background 1 oxygen is there, and tetrahedral shape. Around the silicon 4 oxygens are associated here. The formula is SiO4-4 ion. This is structure of orthosilicate, and this is called pyrosilicate. Like this is a connecting link between 2 silicons, oxygen and silicon oxygen. The formula Si2O7-6. The structure of pyrosilicate. And the orthosilicate and pyrosilicate information, orthosilicate structure, pyrosilicate. And this got cyclic silicates like this, cyclic and chain silicates. The cyclic Si3O4, 3 silicons, and these are the cyclic silicons and chain silicon structure. And this is also another cyclic. Three silicate molecules are associated here. Here 6, 1, 2, 3, 4, 5, 6 molecules. The general formula Si3O9 minus 6 and Si6O18 minus 12 anion. The structures of cyclic silicates. The information about chain silicates and cyclic silicates. And sheet silicate, they are all sheet silicates. More than 5 and above silicates are associated to form sheet silicates. And these are the model questions in 4th group elements. You see, which of the following is a carbide consists of C3 minus 4 type of anionic part. C3 minus 4. So the answer is D. And which of the following factor is mainly responsible for toxicity of CO gas? On 4 options are there. And in the following reactions, the lead compound A and B are respectively Pb3O4 react with HNO3 A compound and Pb3O4 react with the HNO3 B compound. What are the A and B? And the lowest melting solid among the following elements: silicon, lead, germanium, and tin. So these are lowest boiling point. In the table, so these are the model questions we are expecting from 4th A. And these are another questions also. SnO2 is insoluble, and the water replicable characteristics silicones. The silicones low bond, the strong SiOS bond untunda, low surface area, and have a high van der Waals forces in presence of alkyl group pointed towards surface. These are the questions. And now the 5th group elements. Okay. Now 5th group element. This is also important lesson from PBlock elements. Now you see the 5th year group elements. Shall I continue or shall I stop here?
Continue, sir.
Chepdama, 5th group continue chedama?
Okay, sir.
Right. Okay. Now you come to 5th year. 7:30 close chestan. You see, just 30 minutes you have to spend here. So 5th year group elements. So these are the 5th year group elements, you know already. Nitrogen, phosphorus, arsenic, antimony, bismuth. And this table is most important here. You see, the name is nicogens. Why? Because the compounds are called nicotides. That's why the 5th year group elements common name is nicogens. And these are the group elements. And electron configuration NS2 NP3. And atomicity, in first class beginning lo chepparu atomicity, the nitrogen is stable in N2, phosphorus, arsenic, antimony stable in P4, AS4, SB4, and bismuth is single atom, they are stable. So atomicity 2, 4, and 1. And N2 is a gas, and phosphorus and arsenic, antimony are solids, and N, P are non-metals, and arsenic, antimony is semi-metal, and bismuth is a metal. The atomicity, the metallic nature from top to bottom increases. Why? Because the first 2 are non-metals, and middle 2 are semi-metal, and the last one is a metal. Come to OS of nitrogen. The nitrogen exhibiting multiple oxidation states. You see the nitrogen exhibiting +5, +4, +3, +2, +1, 0, -1 up to -1, 3. So in Nirakala OS, the nitrogen exhibit chestund. So for example, you take ammonia -3. This is called hydrozoic acid -1/3, hydrazine -2, hydroxylamine -1. Any molecule always 0, and nitrous oxide like this. So +5 to -1/3. These are the nitrogen variable oxidation states. And you come to the melting point and boiling point. You see the nitrogen -210 minus phosphorus and arsenic, antimony, bismuth. And these are the covalent periodic properties, covalent radius, and ionization potential values. This is electronegativity value, the 5th group. The nitrogen exhibiting highest electronegativity according to Pauling scale, -3.0 value. In this group, the nitrogen having highest Pauling scale value. And the hydrate now properties, the first property is hydrate, general formula MH3, examples and properties and structures. You see these properties are most important. The first one, the hydrates, you see ammonia, phosphine, arsine, antimbismuthine, stibine and bismuthine. The thermal stability ammonia is a more stable. And bond angle, ammonia 107, 94. The bond angle decreases from top to bottom. And basic ammonia is a strong basic because of the nitrogen is small size having lone pair. And reducing character, the bismuthine is having more reducing character. And these are the properties of hydrates. And these are the other hydrates. Hydrazine N2H4 structure, N2H4, lone pair electrons, and these are the bond. And hydrozoic acid, N3H. And the next one, oxides of nitrogen. I told you the nitrogen when react with oxygen, they gives 5 types of oxides. So the one is N2O, nitrous, NO, N2O3, dinitrogen trioxide. This is called sesqui oxide, nitrogen sesqui, nitrogen dioxide, nitrogen pentoxide. This is a dimeric state. The N2O4 dimer form is N2O4. Both are same, monomeric form, dimeric form. And but overall, the 5 oxides also here, there. And these are the most important, the structure you see. The N2O, generally we call laughing gas. The N2O generally we call laughing gas. The N2O structure like this. You see the N, the central nitrogen exhibiting sp hybridization. The central nitrogen containing 2 sigma, and 2 sigma, there is no lone pair. 2 sigma means sp hybridization and linear geometry. And NO containing a odd electron here. The nitrogen valence electrons are 5 and oxygens are 6. 5 plus 6 is 11. 11 is an odd number. That's why the NO exhibiting paramagnetic nature. And the NO containing 3 electron bond. You remember every bond containing 2 electrons. But in case of NO, the NO containing normal 2 bonds and third bond containing 3 electrons. And the Charles example which of the following oxide containing 3 electron bond? So the NO containing 3 electron bond, right? And N2O3, nitrogen sesqui oxide. This is a symmetric structure like this. This is sesqui oxide. And N2O4 dimeric cis oxide. This is cis, same type of bond, same side cis. And the monomeric form N2O. And this is N2O5 net pentoxide. It is a bridge bond containing. The O oxygen is a connecting between N and N. It is a cis geometry, same type of bond, same side cis, and connect a bridge bond. And this is cis structure. And the bridge bond, NON, and a 3 electron bond containing here. And this is linear. So these are the structures of nitrogen oxides. And the other important one is hydrolysis reaction of nitrogen oxides. So all nitrogen oxides, when dissolved in water, you see the first we observed N2O with water, no reaction. NO with water, no reaction. That's why out of the 5, the first 2 oxides are called neutral oxides. The pH value exactly 7. So does not hydrolyze it in water. So the N2O, NO neutral oxides. Except 2. The remaining 3, when dissolved in water, they produced acids. That's why the 3 oxides are called acidic oxides. Acidic oxides center. Why? Why? Because the N2O3 when dissolved in water, they produced nitrous acid. Nitrous acid. 10 minutes. HNO3. N2O4 when dissolved in water, they produced 2 acids, HNO2, HNO3. And N2O5 when dissolved in water, they produced only 1 acid, 10% ic acid. So you see, you remember, the N2O3 gives 100% us acid, N2O5 gives 100% ic acid, but N2O4 gives 50% us, 50% ic. Okay. Nitrous, nitric. Okay, these are the hydrolysis reactions. Out of the 5, the first 2 are neutral and the 3 are acidic. They produced us acid and ic acid. So 100% us, 50% us, 50% ic, and 100% ic. And now the next one, oxides of phosphorus. The P2O3 and P2O5, P4O8. So it is a monochlorine form, it is a dimeric form. So P2O3, dimeric form, P4O6, P2O5, dimeric form, P4O10. So the next one is important reaction is hydrolysis reaction. 6 when treated with water. There are two types of water we have to use in here, cold water, hot water. If you take cold water, you are getting H3PO3, phosphorus acid. And if you take hot water, you give phosphoric acid plus phosphine, right? P4O6 plus hot water, you are getting H3PO4 plus phosphine. You remember these two reactions are very, very important for competitive examination. So already Ninda Japan, any hydrolysis reaction from PBlock elements, that is the most important. So P4O6 with water cold, acid. P4O6 with hot water gives ic acid. Phosphorus, phosphoric, right? And you see, you take phosphorus pentoxide, treated with water gives metaphosphoric acid. The metaphosphoric again hydrolysis gives pyrophosphoric acid and gives final compound orthophosphoric acid. So the P4O10 gives orthophosphoric acid. These are the intermediates. So these metaphosphoric acid and pyrophosphoric acid are the intermediate. The final compound is phosphoric acid. So overall, all hydrolysis of phosphorus oxides are important for coming examination point of view. Now these are the structures of P4O6, P4O10. Now 4 phosphorus, 4 corners there, and each phosphorus surrounded by 3 oxygens. So the PP bond, POP, 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 POP. So 6P, 4 plus 2, 6 POP bonds are present here, right? P4O10, this is P4O10. Each phosphorus surrounded by 4 oxygen atoms. This phosphorus containing 3 oxygen, 3 sigma, 1 lone pair, sp3 hybridization. And here also each phosphorus exhibiting sp3 hybridization, but the geometry is here pyramidal. It is tetrahedral because one lone pair is there pyramidal. Without lone pair is called tetrahedral. And this is these are the structures of P4O6 and P4O10. Now you see these are the oxides of already covered. And now the next one, halides. The 5th group elements, when react with halogen, gives 2 types of halides. One trihalide and second one pentahalides. Trihalide general formula MX3, the pentahalide general formula MX5. The MX3 is equal to NX3, PHX3, ASX3, SBX3, BX3, right? For example, NCl3, PCl3, like this. MX5, pentahalides, only 3 elements form 3 pentahalides. Nitrogen does not form pentahalides. Bismuth does not form pentahalides. The reason is due to small size, availability of d electrons, the nitrogen does not form pentahalides. Okay, leave it. But bismuth is a big size and vacant d orbital also there. Even though vacant d orbitals, the bismuth also does not form pentahalides. The reason is due to inert pair effect. Due to inert pair effect, the bismuth ion can form only maximum capacity covalence covalent bonds are 3 bonds only, not 5 bonds. So that's in pentahalides, the nitrogen bismuth does not form pentahalides. The remaining 3 are forms pentahalides. Now the structure of MX3. This is MX3, right? The MX3 around M, 3 sigma bonds, 1 lone pair, total 4. sp3, 1 lone pair is there due to lone pair bond pair repulsion. The bond angle decreases. That's why the geometry also changed due to repulsion. Therefore, the geometry is pyramidal. So sp3 pyramidal. And pentahalide structure trigonal bipyramidal and sp3d hybridization. So this is the information about halides of trihalides and pentahalides of the 5th group elements. And the hydrolysis reaction, these 2 hydrolysis reactions are very, very, very important. You see, you take trihalide NCl3 and PCl3. Both are belongs to trihalides of nitrogen and phosphorus. Both are hydrolysis in water. Ready to water dissolve ESM. NCl3, when dissolved in water, they produced ammonia, HOCl. Same in place of NCl3, I taken PCl3. Dissolved in water, they produced phosphoric acid and HCl. So what is the reason here? You see, you remember, very, very important hydrolysis reaction. The water here, in water, H plus and OH minus ions are there. But in NCl3, The N is a more electronegativity because of N becomes minus charge. Ultimately, the neighboring chlorines become positive. So the minus attached with the plus. So N attached with the hydrogen gives ammonia. The attached with the OH gives HOC. It is okay. But you come to the second reaction, PCl5. In P and Cl, between P and Cl, chlorine having more electronegative because chlorine is a halogen. All are more electronegative. So due to more electronegative, the chlorine becomes a negative charge. Ultimately, the phosphorus becomes positive. The positive phosphorus attached with the negative OH. So POH taken thrice. You can write reverse H3PO3 phosphorus acid. And Cl attached with the H minus attached with the plus gives HCl. So Sarika reaction. These two reactions, Kachitanga, one question mark exam point of view. So NCl3 when dissolved in water, they produce ammonia hypochlorous acid. And phosphorus trichloride when dissolved in water, produce phosphorus acid and HCl. So these are the hydrolysis reactions. Okay, right. And now oxy acids of nitrogen. So in the 6 mentioned, but the 4 oxy acids are important here. You see the first one H2N2O2 hyponitrous, first one. Next nitrous HNO2. Next nitric HNO3. Next fernitric HNO4. These 4 oxy acids of nitrogens are important in our syllabus. So H2N2O2 hypo, HNO2 nitrous, HNO3 nitric, HNO4 fernite. Right. Now, in the law, out of the 4, the HNO3 reactions are important here. The nitric acid react with the metals. You remember very, very important here. The nitric acid react with the zinc metal. Dilute, I am taken here dilute HNO3, concentrated HNO3. Suppose I am taking dilute HNO3, react with the zinc metal, gives N2O gas, laughing gas produces. This is common, zinc nitrate. The same zinc react with the concentrated HNO3, gives nitrogen dioxide. You remember, you catch the point. Same metal, same, but the concentration of nitric acid different. 2 concentrations taken here. One is a dilute and second one concentrate. If you take a dilute, you are getting nitrous oxide. Take concentrated acid, you are getting NO2. The copper react with the dilute. Nitric acid gives NO, is a byproduct. The same copper react with the concentrate gives NO2. So you remember in your preparation, you concentrate this area, the metals. The reaction with the metals with the nitric acid very important. The table important. Okay. So first concentration is very dilute HNO తీసుకున్నాను. Below 1%. Dilute తీసుకున్నాను. Very, very dilute. Okay. Very dilute nitric acid తీసుకొని metals మీద interact చేశారు. For example, you take magnesium manganese. Metal nitrate is common. Nitric acid with react with iron, zinc, tin, ammonium nitrate వచ్చేసింది. ఈ టేబుల్ ఒకటి గుర్తుపెట్టుకోవాలి ఎగ్జామ్ లో. సో సపోజ్ వెరీ డైల్యూట్ తర్వాత యూ టేక్ డైల్యూట్. ఈ మెటల్ తీసుకున్నాను NO గ్యాస్. Taking 2 metals, these 2 metals, we are getting N2O. I am taking tin, ammonium nitrate. And a nitric acid concentrate తీసుకున్నా. Take zinc, iron, lead, copper, silver add చేశాను, getting NO2. Tin తీసుకున్నా. And you concentrate. I am taking 3 varieties here. Very dilute, concentrate. Metals, common metal తీసుకుందాం. Ammonium nitrate, NO, N2O, ammonium nitrate, NO. Nitrate is common. అన్నిట్లో కామన్ గా వస్తుంది. ఏ గ్యాస్ రిలీజ్ అవుతుందో అడుగుతున్నాడు మనం. Which type of gas evolved when dilute nitric acid react with the following metals అని అడుగుతుంటాడు క్వశ్చన్. సో ఈ టేబుల్ ఒకటి మీరు గుర్తుపెట్టుకోవాలి. This is the most important. And another reaction of nitric acid, you see, organic chemistry మీరు రీడ్ చేశారు, ఇవన్నీ కూడా important. Famous reaction, the benzene react with the HNO with nitrobenzene. Nitrobenzene reduction చేస్తే gives aniline form అవుతుంది. Toluene తీసుకొని heavy concentrated nitric acid కనుక చేస్తే you are getting trinitrotoluene TNT. Blasting use చేస్తారు. This compound you have to using in the explosive. So TNT trinitrotoluene form అవుతుంది. These are also nitric acid. And now you see the famous compound trinitrotoluene. It is trinitrophenol picric acid. And this is also important. Cellulose nitrate and nitroglycerin. This is nitroglycerin. All are explosive compounds. ఇవన్నీ కూడా నైట్రిక్ యాసిడ్ తో ఫామ్ అవుతాయి. అండ్ నైలాన్ 66 ఆల్సో దేర్, cyclohexanol and also react with the HNO that are getting addition with the adipic acid you are getting nylon 66. Here also the nitric acid role is important here, HNO3. So they're all the properties of nitric acids. And you come to phosphorus oxy acids. It's all important ikkada okkasari phosphorus oxy acid. But hypophosphorus in the H3PO2 structure OS plus 1. Only one OH is there, mono basic acid, and 2 hydrogens ఉన్నాయి ఇక్కడ, reducing character. 2 hydrogens are attached directly. Here the hydrogen attached with oxygen are not phosphorus, but whereas here these 2 hydrogens are directly bonded with the phosphorus. These hydrogens are called reducing. This acid exhibiting reducing character. Strong reducing, because 2 hydrogens are attached here. You come to second one, phosphorus. Only one hydrogen attached directly with the phosphorus. It is a dibasic acid. 2 H groups are there. Orthophosphoric acid, oxide OS5, tribasic acid, sp3. Now, pyrophosphoric acid, H4P2O7 plus 5 OS. It's a connectingly bridge bond present here, and plus 5 oxidation state, and sp3 hybridization tetrahedral geometry connecting link P. And hypophosphoric acid, it's a PP bond present here. This is PO, and POH, 4 POH bonds, 1 PP bond, 2 PO bond present here. And this is phosphoric acid. And you see phosphorus structure like this. And already I told you, hydrolysis, cold water, hot water, already I given. And this is also there, oxychlorides, nitrogen oxychlorides, and phosphorus polymeric compounds, NOCl and POCl3. The NOCl with water, HNO2, and POCl water, H3PO4. And this is the important structure, general chemical formula. Phosphorus nitrolic chloride, PNCl, taken N is equal to 3, 4, 5, 6, 7. For example, you take PNCl to taken thrice, triphosphonitrile, and you take 4 molecules tetraphosphonatrilyl chloride compound. The structure of PNCl to this is the cyclic structure, alternative bonds, P and P are alternative bonds. Each phosphorus containing 2 chlorine molecules is there. So this is the structure of oxychloride compounds and phosphonitrile chloride structures, and trimeric structure and tetrameric structure. And the important nitrogen fertilizers, you know already in fundamental concept, the nitrogen fertilizers are basically, these are all the nitrogen fertilizer, ammonium nitrate, ammonium sulfate, calcium cyanamide, calcium ammonium nitrate, basic calcium nitrate, urea. These are all the fertilizers of nitrogen. And this is the fertilizers of phosphorus, calcium superphosphate, nitrophosphate, triple phosphate, phosphoric slag, all are belongs to phosphorus fertilizers. And superphosphate on preparation, calcium superphosphate lime preparation like this. And NPK fertilizers, the fertilizers containing nitrogen, phosphorus, potassium in suitable adjacent properties are known as NPK fertilizers. These are obtained by mixing of nitrogenous, phosphorus and potash fertilizers in the suitable proportions. Expression like 482 used for the mixed fertilizers indicate that contain 4% of nitrogen, 8% of E2O5, 2% of K2O4. This is the mixed fertilizer called NPK fertilizers. Nowadays, our agriculture, in our agricultural field, we are using NPK fertilizers. The NPK means nitrogen, potash, and phosphorus fertilizers. And these are all the model questions from 50A. The number of nitrogen to oxygen bond in N2O5 100 question, 3 and 4 or 5 or 6 added, and the bonds. And when concentrated nitric acid is decomposed to gives. And in P4O10, the number of oxygen atoms are bonded to each phosphorus atom. In the Japan structure HN4. And HNO3, we written with the P2O5 gives A and B. And what are the A, what is the B, and the structures. And these are the other structures, N2O5 isoelectron with the CO2. And these are all the model JE questions. The hybridization state of a central atom in PCl5, sp3d, the cl bond angle pcl5 120-90 degrees ఉంటాయి. The bond angle of NH3 BH3 ASH3 sp3 decrease అవుతాయి general గా 107 to 92 degree decrease అవుతాయి. This is answer D. So these are all the questions of 50A, and the remaining 6th, 7th, 8th, the next class we will discuss. And today I can stop here, and remaining within few days, 1 or 2 days, I will finish the remaining 6th group and 7th group and 8th group. So this is the information about PBlock elements. So once again, I told you, and I'm giving the information. So what you concentrate here, the physical property and chemical property important. In chemical property, you have to discuss, you have to read the hydrates, oxides, and the halates, oxy acids of each group element from boron to 8th group or 7th group elements, including 8th A. Okay. So, and each compound, every compound, you have to structural information important. So number of sigma, number of lone pairs, and hybridization, and geometry, and oxidation state, and bond connectivity, whether it is a connecting link or what type of bond present between two central atoms. So the structural information important in inorganic chemistry. So inorganic chemistry anangane మీరు ఏం టెన్షన్ పడదు. Just thoroughly, just structure on paper. You have to practice on paper only. పేపర్ మీద ప్రాక్టీస్ చేసుకుంటూ, సో కెమికల్ బాండింగ్ లో ఉన్న ఫండమెంటల్స్ అంతా కూడా ఈ మాలిక్యూల్స్ లో మీరు ఇంప్లిమెంట్ చేస్తే మీకు ఈజీగా మీకు అండర్స్టాండ్ అవుతుంది. సో రిమైనింగ్ విత్ ఇన్ 2 days I will finish the remaining chapters also, a pending chapters like 6th A, 7th A, and 8th A finish చేస్తాను. So okay, any doubt from your side?
No, sir.
Okay na? నేను ఇవన్నీ మీకు షేర్ చేస్తాను. ఒకసారి నోట్స్ కూడా షేర్ చేస్తాను. అగర్ వేరే నోట్స్ కూడా ఉంది, అది ఒకసారి పంపించేసి మీకు షేర్ చేపిస్తాను. PBlock ఎలిమెంట్స్ మొత్తం నోట్స్. ఓకేనా?
థ్యాంక్ యూ సార్.
మళ్ళీ ఒక 2-3 days లో మళ్ళీ మనం కంప్లీట్ చేద్దాం. ఓకే
సార్, థ్యాంక్ యూ సార్.